Hello, everyone, and thank you all for joining today's tech session. Today, we are looking at production and testing environments, and Ramsey is going to be leading today's discussion. The session is being recorded, and the recording will be available on our YouTube channel. If anyone has any questions, please feel free to drop them in the chat or raise your hand. We will be saving a bit of time at the end for questions. So yeah, with that said, I'm going to hand over to Ramsey. Thank you. Ramsey, take it away.
Thanks, Mansi, for that introduction. So I'll ask quickly, just first, are you hearing any background noise from my side?
No,
I have a fan on here because it is deadly hot today.
No, it's fine. We can't hear the fan.
It's great. Share my screen. You can type in when it's screen share is coming through.
There we go. We can see it.
Hey, great. Welcome, everybody. Today we're going to taking you through kind of the concepts between how production and testing environments are used and are useful in the kind of AI space, and how we can use to move efficiently and effectively drive your AI production use cases. So firstly, I'm just going to talk a bit about what we're going to talk about. This is the index to show what we're going to be going through. So first, we're just going to be talking about defining what production and testing environments actually are, so we can talk about the same thing. I will mention in that page, generally in the tech world, we speak more about the dev environments and the development environment, and we're talking about testing environments. So going forward, obviously, we're using dev or development environment. Then we're going to talk about how to separate those two different environments, talk about the key differences between those environments, and then how to transition between your development and your production environment once you have your new features set up and stuff. So since this is kind of looking more from an AI lens at these things, we want to incorporate that at the end, but from most of the steps, we're just going to be talking about this in a more general fashion, since these practices apply to practically every tech environment, not just AI specific. So again, talking about in general, and then at the end, we're going to just talk about more specifics around the AI world and how that will affect everything. First off, let's just define what these things are. I'm going to have a visual interpretation of how you go from kind of the unformed clay to the solidly shaped cube there. But essentially, our testing environment is the space where developers are going to be playing, where they are going to be designing new things, thinking up new use cases, playing with them. So obviously, in this environment, the user will never reach this environment. This is a space entirely for developers. And because of that, because it doesn't need to be the stability and security there, you'll find that errors and bugs and things are going to be commonplace, but that is just a byproduct of kind of fast testing and turnaround. Since the key kind of outcome here is to get the functionality working. It's not about errors. It's not about optimizing it. It's first get something to work. You can worry about kind of edge case errors and optimization, all of those things later on when you want to productionize it. In production environment, this is a space where the users are actually interacting with your platform or your use case. This is a live setting. It's going to be using all of your live data. So obviously, it's going to be a lot more GDPR and POPI constraints here, which in your dev environment, you have to worry too much about, since you're using, or hopefully you'll be using mock data and not real data. So this environment also needs to be fully operational, secure, and optimized to get the best performance for the user. Usually what does fully optimized mean? It means it's optimized enough so that the user doesn't have a bad experience and that your resource costs are not too high. And why it's also important for this to be incredibly secure and error-free is that any downtime or errors that creep in will have a direct impact on your user. So you do not want to, or you want to limit your errors and your downtime as much as possible, so the user once again has the best end experience. Okay, so now we know what we're talking about when we're talking about developer environments and production environments. So why is it important to separate these two things? So we have these two environments. Why not just do it all in the same place? So we kind of touched on a little bit on in a previous slide, but prod absolutely 100% needs to be stable and secure. You can't have a person in the prod environment building new things, testing things in the prod environment, potentially changing shared data resources like editing data, using resources that the production will need as it will impact the end user. So you don't want to have that. At the same time, just looking at it from different lenses is, as a developer, you don't want to be stricken by fear when you are kind of innovating and creating new functionality and features by the fear that you might potentially break something. If you end up doing that, your developers will be much less effective. As before they try any new function out, they will have to double and triple check to make sure that it's working right. And sometimes in the dev world, or sometimes most of the time, it is much better to fail fast. So do something and see it break, rather than planning to build it without any errors from the beginning, especially when you're working on new concepts and new functions. Another useful thing to consider is your resource allocation. So if you're a big corporate, the kind of resource in this case we're talking about is things like server space, CPU power, storage, data. All of those things can be considered resources, and you want to kind of separate those resources as well. You don't want your dev environment and your prod environment to be using the same servers, using the same kind of CPU power and storage. Any unexpected outcomes from the dev side might then impact on the prod if that ends up happening. Additionally, with this, also on the dev side, you will find a lot of times you don't need to worry about as much things as you do on the prod side. So you don't need to have such a robust framework and set up in the developer environment. If you only want to test something very specific for features, you don't have to worry about scaling up new or dynamically scaling servers or data security or all those things. So you can have a much smaller, much reduced environment when you're working in the dev space, sources and total as well. And I talked about the prod, you don't want the kind of unexpected load coming through from the dev side that can affect the production side. So separation is a necessity. So in theory, you could have them in the same place and just make sure that your developers are not abusing things, but it leaves a lot of assumptions that people are going to behave not like people. So it's better to have these environments separated so that people can be people in the dev space. And when you are thinking about touching the prod space, then just have a lot of protocols and procedures in place so that people are not affecting anything different. All right, so let's talk about kind of the key differences. So we have a general idea of what the prod and the dev is, and understand why they need to not be together. We should talk a bit more in depth about what the key differences are between them. So with our functionality and purpose kind of part of it, so your production side is essentially going to be focused on delivering finished product. Error-free, it's going to be secure, it's going to be polished, user-friendly. So a lot of things that you might not necessarily think about when developing a feature or a functionality is how the end user is going to interact with it. As a developer, you don't need to understand how an app might look if you're building a model recommender. You just need to know that model is recommending the right thing. But once it gets to the production side, there's a lot of extra steps to actually present it or serve it to a customer in a way that's consumable for them. And those are things that the developer, in this case, doesn't have to consider. And also on the dev side, you want to be extremely focused on this kind of flexibility and reiteration. So you want to be quick and fast. So it's completely unpolished and you only want to get new things out quickly. If we look at it through the lens of stability and risk, so our production environment, as we mentioned before, must be incredibly stable. We want to promote and focus on a lowest possible downtime and a very low error rate. So ideally, it will be zero, ways to strive to be perfect in there. You also want to be constantly monitoring your production environment to make sure that if any errors or unusual activity is happening, that could potentially indicate a bug or error. You want to have a robust kind of alarming system that can crop up and say, something is wrong, have a look. And then if anything is wrong, you want to have this kind of rollback options, make sure you have versioning in place that allows you to roll back to a previously stable version if anything goes wrong. What you have to take into account is that any risks in most cases for a production environment is going to be upgrading it to a new version. So if you want to take any risk there, do it with extreme caution. You want to make sure and you're doing it in the most stable possible way. You can either do this through using phased deployments or using rollbacks. So if anything does go inherently wrong with a new feature deployment, then you can very quickly roll back to the previous stable version. Obviously, with dev environment, there is going to be a lot of risk that you're taking every time. You're building new things. You're not worried about the system breaking. If the whole dev environment goes down, it's not the end of the world. You can just spin it back up. So if the system is out for an hour, your company is not losing money. You're just not developing anything for an hour. So you can take a lot of risks there. And by taking lots of risk, you can get continuous feedback on what you're doing. So you are very quickly trying something out, seeing it's working or it's not working, or if it's breaking or causing errors, and you can then very quickly kind of iterate from there. Additionally, if you do work in the dev environment, it's still useful to kind of use version control, just so if you are building a new version of a particular feature, you know, try and update it with perhaps a new optimization built in or some other kind of functionality of that feature that you want to extend or improve. Then you don't have to worry about breaking the previous version. You can just play around with it. And if you get a better result, then you can register that new version. If not, then you can just either discard it or just keep it run. But you still have the previous version that is solid. Then looking at through the lens of user interaction and accessibility. If you're using interaction in the prod side, the user is always going to require performance and availability. So availability is just going to be uptime. You want to make sure that your servers are up as much as possible. And you want to make sure your servers are responsive and perform well. So you want to make sure that the load that your users are demanding from your service is enough, or rather that your service can handle the load that the users are on. This can be done through a few ways, by just knowing what your load is going to be beforehand and provisioning all of the required resources, or having dynamically scaling resources depending on how you want to go about that. And then accessibility and user experience is also very big. In this case, accessibility is just kind of thinking about things like how the user might need to interact with the system in a way that's not the most obvious one. So if you need to have disabled users that are visually just impaired and need to have a passcode or a capture code returned to them in a voice instead of reading up the screen, all of these types of things need to be considered so that the user can interact with the system in a sensible way. And the user experience is also very important. So accessibility and user experience kind of play the same role, just on different angles, giving a good experience versus making the user able to interact with the system in a usable way. And obviously on the flip side, these things, accessibility and user experience, is almost not considered at all, as essentially the only thing that you are concerned about is if the developer can kind of get the insights from the tests that they're running. Accessibility is more for, in user experience is more for the developer itself. So you don't have to take wide array of people into consideration. It's just about the actual developer that's working on the particular feature that they're building and if they can get the outputs that they require. And obviously, the environment end users don't have access to it. So you're not going to have large volumes or large loads coming through. So performance is, as long as the performance is good enough for a single user to test. At that point, obviously, once you start getting into the point when you want to start pushing this from dev to prod, then the dev environment will actually need to start considering performance, but we will get to that in the next slide or the next two slides. So now we are at the point where we want to consider what do you actually need to do. You have a user or a developer that's set up a new feature, a new functionality that they developed in the developer space, and they want to deploy this to the production environment. What steps need to be taken at this point? So the first thing that needs to be considered is refining it. So you can have a great new feature that does something very useful and very important, but it might not be production ready yet. So getting it production ready, the kind of wide space of things you can consider, but it's largely going to be about optimization, making sure that it can handle volumes at the load rate that you require, so it doesn't impact the production performance enough that it's a problem, or if it does affect it significantly, then you need to be sure that and it's important enough that it warrants the increase in performance, that it does requisition additional resources, additional servers to handle the additional load from the new feature. You want to kind of implement or make sure that your new feature is also stable, so you can handle a wide variety of data that's going to be thrown in it. So any kind of odd data or unvalidated data, well, can be validating this data at some point, but just making sure that the vast variety of data that could potentially be thrown to it, it can handle in a sensible way and it doesn't fall over and break. In case, yeah, essentially this all just falls under quality assurance, just to make sure that this new feature is doing exactly what it needs to do. So then we get to the point now we have a production ready feature we want to push to our prod environment. The first thing you want to consider when you're transferring over is, this is not something everyone does, but it's just very useful, is constantly in deployment, constantly in production deployments. Essentially, this is just the idea of when you are pushing a new function or a new piece of code or a new whatever to production, you don't want to take your production offline and then spend time to push over the whole thing. You want to have your production online and do all the necessary steps that you need to do to get your second production environment essentially up. And then at the point where the second production environment is available, just swap them out so that you have your production offline as short amount of time as possible. So that's just important to consider. So when you're actually as a user, I've done this quite a few times, is when you want to kind of facilitate this process, is you want to set up a deployment window. So usually this is going to be done in a time when there's low user traffic. So this will usually be in the middle of the night on like a Wednesday or something. The least amount of users are traditionally on the platform. And then you want to go monitor the changeover. So you are constantly in the deployment setting, it's swapped over, and now you want to monitor this changeover for a while. Depends on the use case and how long it might take for potential errors to crop up. But essentially, I think usually an hour is good enough. You change it over and start monitoring it. So first thing that could happen is that immediately just breaks. That sometimes happens, but usually that's not going to happen if it was tested properly, and then it will run for a while and you're going to start seeing it. Is anything happening unexpected? So you have robust monitoring tools to make sure that you can track everything that you need to track and see if anything unexpected is happening. If unexpected things are happening, you can kind of go down two routes. You can either try and fix it in real time. Maybe it was just a very basic thing that was overlooked that caused an error that was transferred from the developed environment, and you can change it in that time. Or the safer option is to just roll back to a previous stable version. So just discard the changes you made, roll back to the previous stable version, and work on the fix offline in the development environment, and then set up a new transfer at a different time. What's also important now that you kind of went through these steps is to always kind of try and learn and improve on these steps. So there's all going to be challenges that are specific to your industry or your environment that is not going to be seen anywhere else. So it's always important to kind of document and register, just document these processes, these transition processes, so you can see what previous teams or previous iterations, what happened there and where were the pain points. So that those can be flagged as problem points, and that for the next transition they can be focused on to make sure that those problems don't crop up regularly. And then along with the documentation, just review the documentation and the process with everybody involved, so that that knowledge is not just sitting in a document somewhere, people are aware of it and the knowledge is circulating with them. So just like kind of part of the transitioning, but also kind of a bit more generic, kind of common challenges, just when you're kind of talking about this kind of prod versus dev thing. So we're looking at kind of three lenses here. First is our kind of bugs and the error part. We kind of roughly touched on this already. But yeah, so essentially when you are sitting in your prod environment, obviously in the transition, you're going to be paying a lot more attention, but you want to make sure that your prod environment always has robust monitoring for errors, logging of the whole processes so that you can track what might have led to an error, and to have a rapid response team to these, if any errors or bugs are picked up, just so it doesn't sit around for long, and you can then potentially roll back to a previous stable version if that is required. This is not talking about from outside the transition window that we talked about before. It's just in general, when something was transferred and then a week later an error pops up, you still want to be able to respond to that rapidly. Iteration process that we talked about before, and reviewing all of the transition processes to make sure that you're getting the best results, but you make sure that all of those errors or issues that you picked up in the transition are logged, and that the users are ensuring that these bugs and errors that was picked up before are tested thoroughly so that they don't occur again. You can also use simulate user interactions in your dev environment to make sure that the behavior of the data in your testing environment looks as close as possible to the reality it's going to face in the production environment. So you can use automated testing is going to be very useful here to help you simulate the interactions. The simulation is going to be a simulacrum of the real thing, and you want to get as close as possible to eliminate most of the bugs, but you might still pick up bugs in the production environment at some point. Then we also look at speed and quality. So these two kind of factors, and when we're talking about speed and quality, I'm talking about the speed and quality of developing new features. So these two fields are kind of inherently in contradiction with each other, because ideally the production side of it would like the newest features as quickly as possible, and they must be as stable as possible. But speed, the quicker you introduce new features, the less stable they're going to be. Stable features require more time to develop. So it's kind of a slider that you need to pull up and down and find the balance that works for your particular cases in your team. Obviously, there are a lot of steps you can do to kind of mitigate this a bit to get us faster without sacrificing quality. It's just going to be automated testing curve and using retrospectives to kind of help the team look back and see what were the points where we lost quality and how can we kind of reduce that in the future so that we increase the speed and not the quality to make that work. Then we're going to talk about kind of look through the lens of data consistency. So you're going to touch briefly on this, some of the previous steps, just to talk about it a bit more specifically. In this case, when I'm talking about data consistency, I'm talking about the effects of what kind of input data into your models or your system looks like when they are not the way they should be. So if the data is always perfect, life is great. But if you've ever worked with large data, you'll know that the data is not always going to be perfect. There's inconsistencies. There's going to be data that is formatted wrong. There's going to be data that is blank. And you need to know how to kind of deal with this. You need to make sure that you have strong kind of data validation practices. That essentially just means you need to have a protocol to know how to deal with each kind of edge case that might pop up with how the data is not perfect. Deal with that in reality. A way to kind of help just to keep this data as consistent as possible across the two environments is to use data mockups. So essentially you want to take a sample of your real world data and remove any sensitive data that you can, or anonymize the data so it's not infringing on any data security compliance. And you want to make sure you're not using the perfect data. You want the data that has potential errors in them there as well. So you can then take all of that into account, and when you're transitioning over to the production, that switchover is seamless and so all the things are really taken into account. Additionally, you also want to kind of enable some kind of version control for your databases. So when you are collecting data about customers interfacing with your system, at some point you're collecting 10 points of data for each interaction, and then you want to upgrade it to a new version where you're taking 2 extra points of data into consideration. You want to make sure that all of those changes are well documented and versioned so that both the dev and the prod environment knows that they're working with the same kind of data. It is aligned on both sides, especially when you are doing the transition steps between them. Important. So what we talked about on these previous slides were more generic for the tech environments, just showing how these two kind of environments work together and you're going to go from one to the other. How we need to consider or think about, in particularly in the AI space, as we talk about down here. So the development environment is going to be focusing a lot on things like model training, feature enrichment, hyperparameter tuning, and data pipelines. I'm talking about the kind of all detailed process of getting the data from all the sources, doing all of the feature enrichment on it, getting the data into that proper point where you can start doing the model, asserting the data to the model for the scoring. So all of those things are going to be kind of set up and tested in a development environment. Essentially, the majority of the AI or the model process is going to be set up there. And when you get to the production kind of side of it, it's more going to be monitoring and making sure that the thing is performing the way it should. You're going to be kind of monitoring the performance, and if you're using dynamic models, you're going to be looking at things like model convergence to make sure that your model is essentially performing well. But you also have to take into consider things like model drift and how the performance can degrade over time. The dev environment is going to be majority time used for kind of developing new models without impacting the dev environment. So you're going to be usually with, like I mentioned, I think before, is the dev environment is not going to need as much power. But in the AI space, your training models can require a lot of resources. So you want, especially in this case, have that separation, because if you are training kind of billion parameter models, that can take multiple days or weeks, depending on the scope and size of the models, and it can pull a production environment to the ground. Make sure those are separated and then not touching each other, because that can lead to big problems. And then the same thing that we mentioned before, but just kind of pertaining to models, is just essentially once your models are set up and trained properly, you essentially just push the model to the deployment environment. And then you need to track the performance of those models and make sure that either the model is converging as it needs to, if it's a dynamic model, or it is giving good uptick or lift to the attribute you are modeling for. And if it's not performing, just roll back your previous models. Additionally, you need to consider it's just a model drift, so it's not going to be that your model is performing well, it's going to be performing well for the future. These models can degrade if user behavior changes. So you need to monitor for that as well. And if performance becomes below some kind of pre-established limit that is required for the use case, then new kind of models need to be approached. And we'll start stepping, you can start developing these new approaches, looking at logs that your kind of monitoring is creating and seeing why user behavior is changing, or what the model can, how the model can be changed to adapt to these new behavior. Kind of set that all up in the dev environment, and then as soon as you are ready, you can just push it back in. That's going to be an iterative process. You're going to keep on doing it. And that's essentially it. So I don't know if there's any questions from the gallery. Are there any points that weren't clear?
If you don't want to ask your question, you can always drop it in the chat and we can read it aloud if anyone would prefer that, or you can raise your hand. I think you covered everything and everything was very clear.
Thank you, Ramsey. It was very clear. It's an environment that I'm not used to. Very, very nice presentation. Thank you very much for that.